Hi, everyone. Thank you so much for joining me today. I think the last time we had one of this session was like 2-3 weeks ago. So it's really good to be back. And I'm super excited about this session. We have Michael. Michael is a senior developer evangelist from GitLab. And we've been in conversation with him about this for a while now, which is really exciting that he honored us to be part of this. So today we are going to be talking about getting more efficient with CI/CD. And I would like to welcome Michael. Hi, Michael.
Thanks for having me. I'm hoping to provide you some insights and yeah, trying to show you what's inside in CI/CD and best practices and the like. I know that we have talked about like which language we want to go for, and I know that you all probably know, was it Node.js and Angular? The problem is I don't know that, or I don't have deep knowledge inside. So for today we will be looking a little bit into Go, but don't be shy or don't be like feel unsafe about it. It's just like getting used to fixing code, getting to see how the processes work, and in the end we just should be having a good time and learning something. That being said, I will quickly share my screen, and I will also share the URL for the slide deck with you, just because you can follow along for the exercises. So if you want, you can follow the exercises as we go along. But before we kind of start into everything, just a quick introduction. Okay, today is about GitLab. If you want to reach me on social, on Twitter, on LinkedIn, on gitlab.com, it's DNS Michi, which is DNS M-I-C-H-I. Michi is the lovely form of Michael in German. I figured later that it's hard to pronounce in English. But yeah, once you got a nickname, you cannot change it somehow. I'm coming originally from Austria, moved to Germany, to Nuremberg a while ago. I've seen lots of things related to infrastructure, monitoring ops, being a backend developer myself. Started out with C and C++ some years ago, or at least I think 20 years ago, actually, getting old. Yeah, and at a certain point, we got used to automating things, trying to get more efficient, moving on from Git to GitLab, GitHub, Bitbucket, whatever is out there. And so I found my passion for also providing trainings and making everyone like aware of what's possible, what we have. Yeah, and in 2020, or at least in late 2019, I saw a job at GitLab for a developer evangelist. And I thought of, well, I'm an educator, I'm passionate about things. I love to talk about new technology. And so I applied for the job. And thankfully, in March 2020, everything worked out, except for traveling. But we will go figure and try to make the best out of it. And the best thing about like doing this now is that I can show you something, even though I'm located in Germany and you are located somewhere else. But yeah, that being said, in the next, I would say, hour or something, I want to dive a little bit into like, what is GitLab? What are the first steps? We will dive into CI/CD, like getting started, learning the terms, choosing or looking into the pipeline editor, which is rather new, and then practicing some development workflows with the Go Tanuki that we will show you later what that exactly means. And I do have some exercises and practices around security, continuous delivery, continuous deployment, thoughts, ideas, just giving you some insights on what to try next possibly. And there are also some exercises for async practice in the slide deck. We can touch base on that. or we open up the session for an ask me anything. Let's try this. I have maybe you have experience with GitLab already or a different system, and you just want to ask a question. I don't know everything, but I'm also not shy to Google together. So yeah, it should be a good session for you to learn, and I'm trying to do my best to answer your questions later on. The project is also public, so if you want to like go along and do the exercises, you can fork this repository. Just click on like over here, then select the namespace where you want to fork it. And inside the project settings in the general section, and I think it is in advanced, you can remove the fork relationship. So it's like on your own pace, because otherwise you would be defaulting to creating a merge request into my repository, which probably is not what you want. Other than that, if I'm moving too fast, or you just want to keep an eye out what I'm doing and learning from that, I would recommend just following the steps and the labs, or practice this later on async. So the project and the slides combine. For some reason, my microphone went off now. But yeah, I would encourage you to the headset is in the weekend already. I would encourage you to practice later on async, so you can learn at your own pace, and there is no hurry to understand everything in this session today. Please ask questions when they come up, or just put them in the sub chat, so we can like dive in later on when the exercises are being done. That being said, when we start looking into GitLab, and you probably open up the dashboard for the first time, you will see that there is like a top header. There's a menu header at the top. When you navigate into the projects later on, you will also see the left-hand side menu. You can do specific actions. It's just like getting used to how GitLab looks and what you can like do in there. So one of the things which is important to know is that you can specify specific things in your profile. So it's like you click on your avatar on the right-hand side or the right upper corner. You can add your biography, but you can also manage things in there. So if you want to sync the Git repository, there's a way to either specify or create an SSH public and private key pair and upload that, or you create your own personal access token for HTTP access, which you can use later on. So this is like to keep your local clients or your clients on servers in sync with the GitLab server repository, or Git server repository in that regard. And there is a bunch of other things you can enable in there, like second factor authentication and other things. The other important thing, or the other thing to know about GitLab when you navigate around, is that there are namespaces, or something like you can put a project in a group, but this group can also be a subgroup of another group. So you can really like structure what you're building, what you're doing, and you're not bound to like the upper level projects in the same namespace. The important thing about groups is when you're assigning specific permissions and roles, for example, maintainer, owner, developer, reporter, and stuff like that, this gets inherited to the projects below. So you can build up your own permission level and say, okay, for our project, the initial creators are all owners, then we add maintainers, and specifically if we need to grant access for someone else, we can do that on a day-to-day basis, for example. You can also add mention a group in issues, in comments, and other things, which means you don't need to like type all the names with an add mention, but can like say, hey, I wanna mention the dev evangelism group, for example, or the marketing group, which we sometimes do at GitLab ourselves, because we use GitLab to develop GitLab or to create GitLab. Yeah, there are some other things which you can try out. So I will be jumping rather fast over the topics. But I would encourage you to explore what is possible and how to use GitLab in that specific regard, so that you can combine it with the knowledge about CI/CD, which we'll be jumping on in a little bit. You have issue lists and boards. You can search for issues. You can use labels to group them, to make them more discoverable. You can search by author, by milestone, by due date, by the most thumbs up for requested feature or something like that, depending on what you're planning to do with GitLab, like using it for your own open source project, or specifically something else. Other things to highlight to mention is so-called issue templates or merge request templates. The idea is that you provide a skeleton or a template with the most important questions to reproduce a problem. So you don't need to go back and forth and play ping pong on specific things, but rather provide the, like, something is not working. Okay, here are the steps. Please describe. Please describe the steps, and then you being the developer can just go ahead and start trying to reproduce the problem or start working on specific things, rather than needing to ask too much in advance, which is also important, like different time zones, and you cannot just do a sync call for solving things. The other thing, when you start planning and managing your work, is you create issues, you assign them to milestones. You can create, or you can add due dates, meaning to say you get a reminder when an issue is being due. And yeah, this is basically what's inside. The other thing I would recommend checking out are use cases labels, which provide you just a visual overview to see, oh, this is a bug, this is a feature. But they can also be used for search filters, for creating your own issue boards, for like project management, getting an inside view what needs to be done, what is a priority, and other things. GitLab also provides so-called scoped labels, which allow you to, for example, have a state inside, which means workflow in evaluation, in development, in testing, and so on. But yeah, the other thing which we will be looking at in a bit is there are different editors inside GitLab. So there is like the static site editor, which is the basic editor for just editing a file, fixing a typo or something. And the other thing which is provided in the browser is the so-called Web IDE, which allows you to have a file tree on the left-hand side and to edit specific files in the repository, or to add files and then directly commit it, see the CI/CD being run, and so on. This isn't a full-blown Visual Studio Code editor, but it provides certain capabilities to, for example, preview Markdown and edit the main things. And it also has syntax highlighting, for example, like to see whether this is being a comment or a specific code. Before we jump into CI/CD, yeah, project activities are also a good thing to get an insight into what's going on. And last but not least, when someone mentions you, or you get an issue assigned, or something else is happening and needs your attention, there are so-called to-do lists. So you can also add your own to-dos when you're inside an issue and say, okay, this is something I need to check out later on because I cannot change focus right now. You can organize your to-do lists and check what needs to be done, mark them as done, filter them, and so on. This is a good way to immediately see what needs to be done. And when someone mentions you, it has more priority than, for example, an email and something like that. But without further ado, the next to plan, manage, and also like create and store something in your Git repositories, we also want to test it, and we don't want to manually test things because this is like kind of boring. It also like proves it works on my machine, but probably the software shouldn't be just be running on your local machine. It should be delivered on Mac OS, on Windows, on specific Linux distributions, on iOS, on Android, on maybe ARM as a different hardware architecture. And for that, we need systems to do that for us, and also in a defined infrastructure, in a defined way of saying, okay, it just runs in the background and tells me that the code is not working on the ARM architecture, for example, but it works on Linux or on x68 architecture, for example. But it should be running automatically, and best it runs all the time and not just when I'm taking a new release and I'm giving it to our customers and they say, yeah, it's nice that you released that, but actually it's broken. And you burn out from hot fixing the releases and hot fixing the hotfix and stuff like that. So really like shifting left or starting to use continuous integration is a good thing. In GitLab, this is called CI, which continuous integration. CD is continuous deployment or continuous delivery. But for the main part is like we need to understand certain keywords, certain concepts around it. So there are different systems out there. In GitLab, when something is being run, a unit test, a compile step, an automated release generation, a deployment into production, this is being done in a job. So a job executes something. A job is organized in a pipeline, which can be grouped, or jobs can be grouped into so-called stages in the pipeline. Sorry. And we can also have environments. So we have, for example, a dev environment, staging, production with specific permissions and so on. When we want to parameterize or instrument a specific job being run, we can use environment variables, which are being passed from the CI/CD pipeline configuration to the actual job being executed. And the jobs also provide artifacts, which are basically outputs, could be a binary file, could be a table for the release, for example, can be a generated documentation, can be a unit test report in a specific format, can be a security scan report, and so on. So this is important that this is being passed from the job back to the pipeline, to GitLab itself. And the GitLab runner is also important because this is a separate component to GitLab. It communicates with the GitLab server. And the idea is that it can run anywhere. So you can run it on your local desktop if you want to. But it doesn't really matter whether it's like Mac OS, it's Windows, it's Linux, can basically run everywhere. And it can also be run, for example, inside a Docker container, or you deploy it into your Kubernetes cluster, scale it in the way you need to. And the good thing is you're not bound to just one runner instance. You can have multiple runner instances, either assigned to a specific group. So, for example, you have a group of projects which require many resources, C++, Rust, needing compilers. So you can assign more hardware, more resources for this runner group. If you want to package a web application which doesn't need so many resources, you can use low end sounds odd, but you can use less resources, less resource usage runners, basically something like that. And it also allows you to like find granular scaling, whether you need that or not. On GitLab.com, we will be using the shared runners, which means that we can access shared resources. Sometimes we are just in a queue, so the jobs could be needing some time to getting started. But we could also, for example, this is something we won't do today, but you could install your own runner, and then you're not bound to any like credit card validation, but can use your own shared runner. You can also self-host GitLab. So if you want to run it in your own cloud instance or in your own DM set or everywhere else, you can also just install it yourself, install the runner yourself, and just have your own environment. So you're not bound to the SaaS offering on gitlab.com. From the methodologies around CI/CD, this is like a typical workflow. You start coding, you commit your changes into Git, you push the code, and then the CI pipeline runs the tests, or builds the code, runs the unit tests, integration tests, anything around that. And from there, it's moving on into the continuous delivery, continuous deployment pipeline, which means you do a review, you deploy it into a staging environment, and when everything is passed or has passed, you deploy it into production. The idea is that you can do continuous delivery in a specific sense of you don't have a manual step which waits until someone approves that production gets updated, but you do that automatically. The other things to know or to mention around CI/CD is like pipelines are not just like a pipeline where you build a car and then the left door gets added and the right door and so on. But you can also like build something which is asynchronous, a directed acyclic graph, for example, with different dependencies, creating non-blocking pipelines. You can span pipelines over multiple projects whenever this is needed, trigger pipelines in parent-child ways, meaning to say you have a non-blocking deployment pipeline, and it gets deployed on multiple microservices, but the entire pipeline itself is just free for more resources. Yeah, and there's many more to that, which allows to adopt it for your own purposes. Well, but our purpose right now is just we want to dive into a little bit how to work with CI/CD, and this is a workflow, how it's being done in GitLab. So when we start work from like creating an issue, and we create a Git branch, we push the changes after a while, and then we create a merge request. In that moment, mark it as draft, for example, and continue working outside of the main branch or the default branch in Git. And get feedback while we develop along. So when I'm, for example, adding a new feature, changing the backend or improving the backend, hopefully there are unit tests which prove that something is wrong or that I introduced a regression, which can be seen in the merge request itself from the CI/CD output. And when I see that, or the developer who needs to review the merge request, you can say, okay, this is not, the tests failed. We are not going to merge this. You need to really fix the problems which we detected here. And this whole review goes on into like opening up the difference, checking the code style, discussing certain implementation, and when everything gets resolved, it gets approved, merged back to the main branch, and then deployed, later on released when the release is due, and so on. And in order to do that, and to really add CI/CD, there is the format, which is YAML, but don't worry, you don't need to be a YAML expert for that regard. There are, of course, cheat sheets and resources, also online linters for this. If you want to dive into it, if you want to learn it. Most recently, we added the pipeline editor in GitLab. So it's like an online editor in the browser, which understands YAML, and also gives you live linting for the specific syntax, which we will be trying out in a moment. Because in YAML, there is a specific way to use indents to create arrays and lists. And sometimes I'm making the mistake myself, and then I'm like committing it, and the CI/CD pipeline is broken because the syntax is wrong. So in a specific sense, you can call it like CI/CD as code, or pipelines as code, because you're describing what's going on with the YAML syntax. The idea is that the pipeline editor provides you with even more insights, how the pipeline looks and what else can be like simulated beforehand, because it can get quite complex over time. The most simplest idea, or the most simplest way to try the pipeline editor is to say, okay, I want to run a job, which in this example is all underscore tests. A job has the requirement of a script attribute, which runs commands. And a script attribute can run either one command or an array or list of commands with the dash as a bullet point. And this is being executed. You can also specify an image, which is a Docker image, a container image, which is being spawned by the runner. And inside, you execute what's defined in the jobs. And in order to see what happens here, we can just go ahead and say, okay, let's try this example. Navigate into the project, which you probably have forked, and you can fork it right now, into CI/CD and the editor, which instructions, okay, you don't have any pipeline right now, but we will be defining it in the .gitlab-ci.yaml file. And to just make it easier, we can just generate it and get into the view. You can see here that the pipeline editor provides you with some examples what you can do. So it's like the first thing to success. In our example, I'm just like removing this and say, okay, I want to start really, really simple. By specifying image, which should be Alpine latest. And you can see at the top, something is moving. So it says the CI configuration is invalid, and job should be, we need a job. Okay, then maybe let's define a job, which should be all tests. And the job name. So at the top level, there are specific keywords which are reserved, but the job names are free. So you can call it GitLab 1, you can call it build.0 or something else. Just find a telling name so that you immediately know what's going on. We need to define script. And the nice thing is I'm pressing enter and it does the indent for me. And we want to call a shell command, a bash command, which is in this case just exit1. From there, it says the configuration is valid. This is nice. And I'm a fan of good commit messages at CI/CD config. And we also want to commit to a different branch, which should be CI/CD, probably. It doesn't give the instruction here, should fix that. And we also want to create a new merge request from that. So we just want to leave this scope, and we create the merge request. We'll be checking in a bit what else we can do. The thing we can see here is that the pipeline is being run. And when we, for example, click on the pipeline itself, It was really fast being run this time. We get the overview of what's going on. We can see the pipeline, we can see the jobs. And in this case, the job failed. So we can either go here and say, oh, we want to dive into the detailed view of the job output to see what is going on. And we can see that the runner pulls in the Docker images, spawns the context of the container, prepares some things, and then executes our command. And since everything except the except 0 is an error exit code inside GitLab CI/CD, it fails. So this is an intended fail for this exercise. In order to say, okay, how does a fixed pipeline look like? We can, for example, navigate back into the merge request, which is highlighted as an exclamation mark and the number of the merge request. And we can look at the changes, for example. And yeah, basically, I'm missing a button, but we can just go into the pipeline editor, and you can see that there is a branch selector, which allows us to check out the previously changed GitLab CI/CD configuration. And we can move on and say, okay, we're simulating a fix now, fix pipeline, and commit the change. And we can see in the pipeline editor already that the pipeline is being triggered. So I can just click on this over here, see what is happening. These are the changes, and it's running. I can navigate over here, and again, it says exit 0, job succeeded, everything is fine, everything green, the pipeline passed, and follow-up stages or follow-up jobs will be executed. The deployment happens, and so on. So this is like the basic example of getting started with CI/CD and the pipeline editor. You are not bound to the pipeline editor. You can use the web IDE if you feel more confident with it. You can create it on your own pace. The good thing about the pipeline editor is that it's not only like an editor, but it has the live linting inside. You get an immediate feedback whether the configuration is valid or not. So it does some checking in the background. And you also have the possibility, for example, to see what it will be creating. So if we navigate back in here and say we want to visualize what will be created from this configuration, I just have one job. This is the default stage. And we can also see what will be done. It's interesting, especially when something does not work as designed, as intended. And we can also see what happens when what is the full configuration which is being executed. Because at a certain point, we will be, you can use advanced methods with inclusion, with job templates, inheritance, and so on, just to make sure that the pipeline configuration is as efficient as possible, and you don't copy paste, or you don't make copy paste errors from too many things. But yeah, it's a tool for getting started more easily and also manage huge pipelines, or pipelines which have more than like 3 jobs inside. For the coming labs, or for the coming exercises, we will be using the pipeline editor, unless mentioned otherwise. And the typical workflow, which is not explicitly mentioned, is like we're adding configuration in the pipeline editor, we verify it with the live linting, maybe discuss certain things, commit the change in a branch, create a merge request, and inspect the running pipeline. If there is something else to that workflow, I will mention that, or it's noted on the slides. The thing or the idea is, okay, we've played around with exit 0 and exit 1. It's nice to see something, but what are like the typical workflows you probably want experience? And one of the things is, well, maybe you have a project already which doesn't have CI/CD, or you just really want to run the unit tests automatically as a first step, and maybe just seeing if the code actually works on a specific target platform. And so I've prepared a project which is written in Go, and it allows you to run. It does something, but actually we are not sure if it works. So the Go Tanuki, inside it is a Go code. There are some libraries attached to it, and there is, for example, the main.go, the main entry point, this function, and it does something, prints something, and we are not certain whether this works or not. And you can, for example, imagine maybe you've migrated from SVN to Git, became a maintainer for this project, or you're joining a company which doesn't have GitLab or any CI/CD yet, and you just want to make sure that you're working efficiently, that everything gets tested, and you also can test the systems the customer is using. So you don't need to create your own virtual machines or your own test environment all the time when a support ticket is being opened, but instead can continuously test it as you go along. And yeah, this is basically the thing about it. There are many more use cases to CI/CD, but in the end, it's like, I don't want to install specific virtual machine or use a different cloud provider, which takes me 2 days to set up, because as a developer, I need to become ops to really understand it. But instead, it should be done in the CI/CD infrastructure, and my code gets tested automatically, built automatically, and that's about it. In order to now test the Go Tanuki, the code, we want to add a basic CI/CD configuration. And one of the things which are important is we can organize jobs into stages. So we basically define the stages as an array, as a list, with build, test, and deploy. This is also the default if you don't define anything, but it's better to I'm following the principle of, I really want to see what is there. It's nice to use templates and such, and predefined defaults, but I really want to define what's inside the pipeline. The other thing which is important for this example, we'll be using a predefined or pre-built environment with a Golang container image. We are specifying some variables which we will be using in a bit, and the first job which will be executed is called format. It's assigned to the build stage, and the script is to actually run go format or go FMT, which checks the basic syntax of the code, and go vet does some further integration checks to see whether the code is actually building or not. These are specific to Golang. You can replace them with npm build or cargo build for C++. No, it's not C++, it's Rust. In C++ could be CMake, something which builds the code or does some basic linting around it to see whether it's actually being built. And in order to not over-engineer this, can just copy this example and navigate back into our project, open up the pipeline editor, starting, because we committed this in a different merge request, start a new configuration, mark all and remove. And for this example, just not typing too much, we see the configuration is valid. And we, for example, will be generating the format job. The linting says just this job, and there is nothing really specific about it. We really want to see what is going on here, and say add CI/CD conf configuration for Go. And branch names are like open to everything. I'm not calling it CI/CD-go. I prefer dashes instead of underscores because they could be hard to type, at least on a German keyboard. And I also want to create a merge request in that regard. And then I'm committing the change, moving on into the merge request. Over here, I have the possibility to, for example, define what needs to be done or what happens inside this merge request. It's basic configuration, and I also get the possibility to preview that. So, for example, I have should be using a merge request template in that regard, so that I don't repeat that every time. But yeah, it's like tasks, and for example, no, this is the red bracket tests, which then gets rendered as a checkbox, which we can tick on later on with developer or maintainer roles. I can assign it to me, for example, assign reviewers, which I can assign, use specific labels, and so on. Now that I can create the merge request, it should have run the pipeline in the background already for the branch we created earlier on, and we can see that the pipeline failed for some reason. So the Go code doesn't work for some reason. Now, when we navigate into the scope, we can see the pipeline, the format job has been failed. We can do the same step as before and just click here and navigate inside. But we also have the tab here with the failed jobs, which basically parses the output and tells us in a shorter way, it says, well, go vet detected an error in main.go in line 12, character 16, or line 12 to 16, I think, undeclared name OS. So when we navigate into the project again and inspect the code now in main.go, in line number 12, we're using OS, which is undefined in the scope. So in essence, we are missing to import library dependencies. And in order to make it easier, in order to fix the problem, we can actually open up the web IDE over here, for example, and fix the problem. This is being commented out over here, just to make it as easy as possible. So we need to include FMT and OS to make the code work. And are we in the right branch right now? No, we're not. Sorry. Going back into our merge request, this was actually what I was looking at. We can open the merge request in the web IDE. So just to move on in the branch we started to create our GitLab CI/CD YAML, we can also just edit the code and fix it over here. We could also fix it in the main branch, but we want to move on from the CI/CD configuration we just added and say, okay, with the CI/CD configuration, we fix the missing imports. So you can treat, can use the same mechanism to commit the changes directly in GitLab with the web IDE, similar to the pipeline editor. And we commit it directly to the branch. So it uses the previously added CI/CD configuration, and now the pipeline is being run again. In the pipeline editor, you can see it either over here with the rocket icon, or at the bottom, there is also like this mini bar, mini sub item. Yeah. If we open the pipeline again, we can see it runs the image now, uses the Golang container image, and hopefully spawns a job soon, or the job is being spawned, but it needs to be done. Let's just check what we're doing here. This is described basically in this exercise. And once the code is being fixed, we can move on and look into more things, what we want to add for CI/CD, and add more testing, add more building, and so on. Now, in this regard, we can see that the pipeline was fixed. If we navigate back into the merge request, we also get the feedback, okay, everything is fine. The indication for merging this back to the main branch is also there. So the tests or the CI/CD pipeline worked, and we are allowed to merge it back. But we won't do that for now because we are not yet finished with the CI/CD configuration. Now, I'm hoping I'm not talking too fast, but in that example, it's like, okay, now I know how the code works. At least it compiles from that specific sense. But what else happens in there? So when this is like the visualization example, which we did already. When we dive further into what else can we do with the code, we can, for example, actually build the binary for the Golang code, which didn't happen yet. This is done by the Go Build script, which has certain flags with race LD flags and so on, and produces a binary. For producing the binary, we previously defined the binary variable, which we will be using. And we also want to make sure that this binary is being exported by the job output, sent to the GitLab server for download for further usage. So we're defining an artifacts. We're defining it in the artifacts entry, which allows you to define the path, which can be either, like in this example, a variable. You could use a dot, you can use wildcard patterns, anything which is important. It's often used just for, like, as I said earlier, for reports, for release tarboards, for anything you want to really like have the runner uploaded to the GitLab server and make it available for later. The other thing we want to add next to the compile job is we also want to test the code. So there in Golang there is like the format of having the main file and then a specific test code, but this hasn't been run yet. So we really want to trigger the Go tests in our example, which we can assign to the test stage. It executes specific Go tests. One other thing which Go allows you to, and this is like specific to languages, allows you to generate a coverage report, which means it checks all the functions which have a test being available for, and presents the percentage. And like 100% test coverage is like a developer move, which you probably will never reach. But seeing a certain decrease of test coverage over time could give an indicator whether code quality decreases or not, and is a way to inspect or to verify what's going on in a merge request. Probably the code coverage should never decrease from a certain amount unless it's specified in the review or in the merge request itself. So long story short, in the first thing we want to do is we add the compile job into the CI/CD configuration. So let's navigate back into our pipeline editor and select the CI/CD -go branch. And at the bottom, we add the compile job. The compile job is being added to the build stage, like similar to here. And since we're using the same stage as the format job, needs is not needed, not required in that regard. But just to see the dependency, to define the dependency, we can also define an asynchronous dependency for the compile job being dependent on the format job, just to be sure. And the second step in this example is to say, okay, we want to add the test job. And the reason I'm not typing it is because it prepares some things. And usually, or sometimes, this is being defined in a makefile already in your project or in a script, or in a tutorial you're looking up on the internet or in the documentation. So yeah, it's maybe copy pasting from Stack Overflow or something like that. I totally would have wished for that like 20 years ago. But yeah, joking aside, we do have the test job, which is assigned to the test stage. So it's executed actually after the format and compile jobs. And we say add compile and test jobs. Now we can see the configuration is valid and the pipeline is being running. Clicking over here again. And it shows us the changes, which is nice. And the pipeline's being run. And this takes a while because every time a new pipeline is being triggered, it starts again from the beginning. So it starts out on the commit hash, on the commit char, which is being triggered, which is being used. This is the current head in the current branch. And you get reliable feedback from every change you make in your Git history. There are ways to speed this up and to use more caching and use that more efficiently. But it's the same as with code. You first make it work. And based on your experience, based on your knowledge, you try to immediately optimize, or you just say, okay, this works now, and I'm refactoring this later on to make it more beautiful, to make it more efficient. Don't try to over-engineer everything. This is a habit which I sometimes have. And instead, it's just like, let's just try to make it work in the first place. The thing which happens here is we can see, when we move back into the stages view, we can see that compile and format have been run successfully. So the compile job has actually created a binary. We can see here the executed script section, and it's uploading the artifacts. So it means that the Tanuki binary has been uploaded to the GitLab server, and over here we can see the job artifacts. And when I click on browse, I can see that there is a Tanuki binary which has been compiled for Linux. If I would be using a Linux platform right now, I'm using macOS. On Linux, I could download this and execute it on my own local host. If I would be wanting this to work on Windows or on macOS, I would need to use a different cross-compiled build. This is way too deep now. The main idea is, actually, I don't want to download this. I don't want to do this on my own. I want to automate this. And maybe there is a way we can just run to do an integration test, run the binary and see whether it crashes, whether the output is expected, what it does, and so on. So beyond running the pipeline, which hopefully worked in full. Yeah, the pipeline is green. What else can we do? And we can basically do what I described just now. We really want to test the binary. We want to run it. We want to do that in the test stage or in a later stage, defining our own. And the job needs the test job being done successfully and the compile job, which generates the binary actually. And the thing which it basically does is it executes the binary in foreground. So we are expecting that something is being printed to the standard output of the terminal. And this is like a dot dash and then the binary being executed. Sometimes when there are no executable writes, you need to use a chmod plus X on the binary beforehand. But in this example, it just works like that. And in order to add that, we can just navigate back into our project now, going into the pipeline editor and choosing the CI/CD-go branch, which we have been working in. And the last example, or the next example, is the test binary, which we created over here. The test job has been run successfully as well. And I said, okay, add test binary job. Committing the change. Should have said, well, should look more often into the CI/CD configuration is valid. And we can see the pipeline is being run again. Can view the pipeline, see that there are more things going on. And we also have like a different view on this, or we can have a different view with the asynchronous dependencies. So we know that can show the dependencies actually. The format job is being run, then the compile job runs. The test job runs together with the test binary job. But the test binary job only runs when the test job is actually successful. So whenever something breaks inside, for example, the test job fails because there is a regression in your code, the test binary job won't be run. And the pipeline breaks early, so you get feedback early enough to actually fix the error, and not everything is being run in the pipeline, which is a good thing, because when a pipeline or an integration test might be running for 30 minutes for some reason, this blocks your reviews, blocks your CI/CD pipelines. And as a developer moving fast, and oftentimes it's like XKCD 303, what are you doing? Yeah, compiling. Nowadays it's waiting for CI/CD builds. You really want to speed it up and fail the pipeline fast to really fix the problems and then continue working, rather than waiting for the pipeline and spending time somewhere else for the 30 minutes. In the past, I was a C++ backend developer, and I had to wait quite often for builds on my local machine, which basically resulted in me spending time in community forums and on social media. But yeah, in the end, it would be much more efficient to stay focused and continue working on the code, fixing the problems, and delivering a feature rather fast. Now the pipeline is being run, the test binary job is executing, and again it's spawning the Golang Docker image. And the good thing is, over the recent years, many programming languages and libraries and environments have created their own base Docker images. So it's not just like us using a Debian image and then installing the dependencies, but we can use predefined images. And in that regard, we're spawning the image, and we're running the binary, and we have summoned our Go Tanuki or Rainbow Tanuki, which yeah, which is basically success for today, and we can stop now. No, just kidding. But yeah, this allows you to play around a little bit, and you can see when you're printing out a URL, for example, in the job, you can link further. So when something is an error, or you want to give some more instructions where to learn more about it, you can just echo or print a URL in your code or in the CI/CD job output, and then you can click on it, and it opens a new tab, and you can learn more about it. I've added an Easter egg to just link to our GitLab community. So if you want to join on in and start your open source contribution journey or learn more about what we do in our community, I would welcome you to join on in or jump on the meetup, join the GitLab community forum, learn about the code. GitLab is mostly has many components. Right now, it's like Ruby on Rails, Vue.js for the front-end parts, Golang for backend daemons. Certainly more things around that. But yeah, back to the exercises or the ideas. What else can be done within CI/CD? Exceeding a little bit my time window, but yep. The thing I've shown you before is there are different views, like the grouping of CI/CD jobs for stages, which allows you to see what basic things are going on. If you're using neat and asynchronous execution, there is a way to visualize that in a different way. So it's not bound to the grouping by stages, but rather to see when is the job actually being executed. The screenshot on the right is what the full solution of this workshop looks like in the end. And it's not bound to that. You can explore it by yourself. You can play around and see what is going on and how to make it more efficient. The other thing which is important to see is, well, we really want to have faster feedback, as I mentioned before, with CI/CD. So it's not only like compiling the code or checking the format or doing some linting. And linting can be used, for example, for Markdown, for writing docs, for everything which has a linter, which can be executed as a CLI command in a container. But we also want to run unit tests, for example, and I'm a developer myself, and writing tests is sometimes like, needs to be done, but it's not fun. But in the end, it can really help prevent regressions where you spend hours or days or weeks or months even on because it's not tested well enough and not prepared. And probably, or I experienced this myself, I knew that I couldn't change this like C++ backend code in that specific line, but a new team member didn't. And they committed something and someone else approved it, and it gets merged. And after 1 month, I see that and say, oh, yeah, I totally wanted to write a unit test for that 3 years ago, but I never did. So basically try to add as much tests or as much automated tests as possible. And it also helps others to really see what's going on. And next to the set unit tests, you also want to look into test coverage. GitLab provides JUnit as a generic or specified format for this. So when the build chain allows you to generate coverage reports in JUnit XML format, you can integrate that into GitLab. And one of the things which works this way, or how this can be done with Golang, is to install a library and then run go test to actually generate this report XML. And this is something which we can just try now and add to the pipeline editor at the bottom. Just quick copy paste, because typing this is quite a lot to type. The main idea is that it runs go test piped into this binary, which then generates the report. This is this is a nice way. The documentation of GitLab holds some more insights and details for the specific other languages. And I think I found this on the internet somewhere, so it's not just us exploring this for the first time. There are resources out there which are helpful. The test unit report can just run in the test stage, but it needs to be run after the test job because it needs this this coverage.conf file, which is needed. So we want to add the test JUnit report and have this hopefully executed right now. So you can see this is actually being drawn here, but when I hover over it, it shows me that this runs independently. It just waits for this. Probably should improve the UI and just move it over here. But yeah, you get the idea of asynchronous dependencies being run. Why this is being run, and the more jobs we add throughout the workshop, the longer the pipelines take. Just some ideas around what else is interesting, what else could be done in a pipeline. And one of the things is, like, you probably have heard, shifting left security, and why do you want to use it? The first thing I want to encourage you is, whenever you're using a secret or a credential in your CI/CD pipeline, for example, to specify the database access for MySQL, for PostgreSQL, and you're using the root password from production, this shouldn't be in plain text somewhere. Or you don't want to add your AWS credentials or key pair somewhere public. And GitLab allows you to specify CI/CD variables also as secrets, so that they are masked and they are passed into the container job, but you cannot print them. You can access them inside the jobs being run, but there is no way, for example, on the interface to see that. So the output, when someone tries to print that, it's being masked. And it helps to really prevent to leak any specific secrets. You can also limit certain environments, certain scopes where this should be visible. But yeah, this is one thing of security. And the other thing around this is, in order to prevent to accidentally add something in that regard, GitLab also provides security scanning, which can be added to CI/CD, which means that, oh, I've seen an error in the chat. Okay, try to make a commit. Maybe when the GitLab CI.yaml file already exists, try to edit this file directly. Or maybe you're using it, the wrong branch. Try checking the branch selector at the top, whether you are in the right scope. Specifically for adding security scanning to your pipeline, you can either do that from the UI or specified in the CI/CD configuration, for example, by adding or including a template which comes from GitLab itself. So this is provided in a self-hosted installation or on the SaaS platform and can just be used. Our repository has the .env file already prepared, as far as I know. Yes, so we are pretending to have leaked an AWS key. So this is not a real key, it's a made up example. But in the end, accidentally, we committed the .env file because we're using it for development tests and so on. And it has our AWS key. And if this is now in a public project, and if I don't recognize it myself, or a friend points me to that, someone else with bad intentions could use that key and consume our resources and generate lots of costs on my monthly AWS bill, for example. And this is something you totally don't want to. So the thing we can do is we add the with the pipeline editor over here. I'm talking too much, losing my voice. We navigate back into the CI/CD Go branch, and at the bottom, and we can also move it to the top, but just for including this over here, we also want to add secret detection. We change the commit message and wait for that. The pipeline is being executed, but we can also like navigate over here in the pipeline view. This also provides us a history of what we already did in the past. And we started today. This was me this week, preparing the workshop. Yeah, now the pipeline is being run again, and we can see that secret detection is actually being added inside the test stage. But again, this will take a while. It will detect our AWS key and tell us about it. Yeah, and if you're using GitLab for open source if you're applying for an open source license, for example, in the open source program, GitLab Ultimate provides an integration into merge requests, but you can also download the JSON report of the security scans in the free tier and just use that for further inspection. The other thing which is important around security, it's not just secret scanning, it's also static application security testing, it's dynamic application security testing, fast testing. There are so many ways you can make a mistake. I have seen things from SAS scanning which I never anticipated to make the mistake myself. So it really helps to automatically test the extreme cases, worst cases you never thought of, and automate this and being able to fix it. So sometimes like changing the access of certain files, sometimes memory is not protected, sometimes it's like user form input is not sanitized, or things you probably cannot really test from an end-to-end test perspective, which can be automated also in CI/CD, specifically with security in mind. I didn't check whether the pipeline is being run. The pipeline still runs, so it just takes a while. Yeah, what else did I miss? Yeah, dependency scanning is also a huge point when you, for example, edit your package JSON or Composer in PHP or whatever is used as a package manager or for dependency management. There might be some dependencies in trying to install malicious code, downloading something which is not intended to, and so on. So vulnerabilities in dependencies and also runtime scanning. Containers are like the base image for a small operating system inside, which can also contain vulnerabilities and much more. That being said, we want to like spend money or spend time on the CI/CD scans in our pipeline as well, even though the pipeline run might take a little longer, because when we have to fix incidents at 3 a.m. in the morning on the weekend because there is a security breach, this leads into burnout, or can lead into burnout, and it's not healthy. So like having this in our pipelines is a great way to improve, to make the code better, and to stay safe in that regard. What other things to maybe check out? Well, there's a thing around like you can automate it even more, have GitLab detect certain DevOps workflows, opinionated templates to automatically build, for example, a web project based on Node.js, or I've recently tried learning Vue.js a little bit, like have this automatically create a container, deploy it somewhere, run it in AWS or in Kubernetes. And yeah, don't need to think about too much about CI/CD configuration. But my recommendation is to learn CI/CD with the pipeline editor to understand what's going on, because when you need to troubleshoot it, when it doesn't work, it's good to know the tools, good to know the workflows and so on. The other thing around, what did I miss? Oh, this is the security slide again. Did I miss something? Auto remediation, yeah. Well, probably should remove the slide from the presentation. Let's just do this now, like I said on Twitter earlier, to someone being nice from TalentQL. What's next? There are many ideas around like what else can you do with CI and following with CD, like the deployment parts, depending on where you want to deploy your application, apply GitOps workflows, add monitoring, add even more security around things. But yeah, this is basically the things. One other thought around, like we're over time, but I would recommend to look into these exercises for async practice, which touch base with test coverage, how to parse it even better, and also play around with the JUnit integration. So there are some examples which add new code and then later on add tests for the code, so you can see that the test coverage decreases and later on it increases again, just to allow you to play around a little more with it. There's also a way to add batches directly to the project, so you don't need to edit the README-MD, just do that in the project settings, and you can see that the pipeline, for example, works. We can actually try that now as a short example while the pipeline is being run. When you navigate into the settings, was it CI/CD? No, it's general batches, and the batch URL is the pipeline SVG, and probably have done the exercise quite often. Can just add this here. This is the preview, and now we have the batch in the project, and everyone who navigates into the project can see that the pipeline hasn't been run for the main branch yet. Okay, yeah, probably you need to merge the CI/CD merge request, CI/CD Go merge request into the main branch to trigger the main pipeline to see the status and the batch. Okay, what else do we have? We have certain tips around merge requests and code reviews. Yeah, it's totally optional. I just try to add as much detail or as much tips as possible around this. I don't have any more efficiency ideas. This probably shouldn't be there. I've seen there are some questions in the chat. Before we jump into questions, I would like you to check out my profiles, and also there was a blog post being published this week which has more GitLab hacks, GitLab ideas, what you can do And you have seen certain things around templates. I would encourage you to also learn quick actions, which are super helpful, and much, much more. You can see the pipeline editor over here. But for example, things which are also super interesting are parent-child pipelines, by example, and so on. But this is way too much what I wanted to show today. Just a reminder that everything, or we're trying to document everything, share everything, and I'm hoping you had a great time today and learned something new. And with that, I would just say thanks for the attention. And if there are any questions, I would say just ask. Test me.
Thank you so much, Michael, for this really insightful workshop. Hi, everyone. Please, if you have a question, you can unmute your mic or just share in the chat box. Thank you.
Oh, yes. Hello, Michael. I have a quick question. My question revolves around what is the pricing like for GitLab CI/CD pipelines? And also, is there like some sort of provisions for free tier accounts that are on free tier? Is there like a max amount of limits you can run these things for?
So if you're subscribing to, or if you're creating a GitLab.com SaaS account, the free tier includes certain minutes you can consume from the shared runners, just to provide you. No, it's pricing. The pricing page. It's the weekend. Cannot type. So there is you have 400 CI/CD minutes per month, which are in the free tier, and typically this should be enough for like using your own projects. One other way is if you, for example, working on an open source project, or you have access to your university, which can apply for, or your educational institution, which can apply for the education program with GitLab, they can get access to the ultimate tier for free in that regard. The pipeline minutes, what happens if I reach my limit? I'm just reading the FAQ. You can purchase additional minutes. To be honest, I don't know the pricing. I need to like click on here, and potentially it's inside the user interface then. But if you say, okay, I'm having the problem, I'm reaching, for example, the 400 minutes limit each month from the shared runners, I would recommend checking out, for example, spinning up your own virtual machine and installing the runner in there. And it just costs you, I don't know what AWS builds. I think you can use the free tier, for example, for 1 year there, and just leverage that and have your own GitLab CI/CD runner from that regard. But from my experience, I didn't really like exceed the limits that often with my private account. Or I cannot remember exceeding it, to be honest. So I think you should be safe and should be fine in that regard. I hope this helps.
It does. Thank you.
Hey, Michael. This is Abubakar. Can you hear me?
Hi, Abubakar. Nice to meet you.
So just to add to what Michael said, I think the pricing of the CI/CD minutes, if you want extra, is $10 per more 1,000 minutes. But when you only exceed the 400 limits when probably you are working in an organization and you run multiple pipelines at the same time. More like you have multiple jobs, multiple stages, and probably you have lots of projects that are currently running CI/CD pipelines at the same time. That's when you can quickly mop up your minutes. And like he said, if you want to run more without necessarily spending for GitLab, though we want you to spend for GitLab, so you can spin up an instance, install a GitLab runner, and do what you want. Some other instances where you might need to spin up your own runner separately is where maybe you need special type of devices, special type of processors. Maybe you need some GPU or you need some Mac to build some your iOS devices. Then you might need to spin up devices, install runner on them that do those specific requirements. I hope that helps.
It does. Thank you, Abubakar.
And the other thing I want to mentioned earlier is when you're expanding your project, for example, in a group, and you say you want to you're developing an awesome tool in the open with an open source license, your group or your project can apply to the open source program, and getting access to more CI minutes when you build complex pipelines, when you want to leverage security features and everything else, you can apply for the open source program, where you can see that like GNOME in their KDE and others, and just to ensure that your group and your passion and your enthusiasm is not limited by, let's say, 400 CI minutes, but instead try to build in the open, contribute, and also being able to benefit from the open source program. The other thing is the education program, but this highly depends on the institution. But yeah, I just wanted to highlight that it's there, so it's it shouldn't be bound to that. And the other thing is inside the FAQ, and I probably should be linking the pricing page in the chat. You can also learn how to really like the step-by-step instructions how to install your own runner on a virtual machine. I recently did an exercise. I installed the GitLab runner on my macOS MacBook because it also works. It's just like you install the binary package, you run the registration steps, you insert a token which you get from the GitLab UI, and then you can like register the runner. It communicates over HTTPS, so the runner contacts the server, and yeah, I think it's super straightforward to be done in like 10-15 minutes and see the first success. And it's also a great way to experiment and try it out and look a little bit around, look behind the curtain if you're interested in how the runner is actually being built, or you want to read the source code, which is also possible, of course. Oops, wrong window. For example, this is where the majority of the GitLab project lives. But for example, the GitLab runner project lives over here. You can see that, or you can learn how the GitLab CI configuration, for example, is being built for this Go project, which, to be honest, I haven't read in a while, but it's highly abstracted. And see how it's being built, how the code works, and so on. And maybe you want to start contributing, or you notice that a feature is missing, and you want to start diving into the code, learn something new. Would totally love to see you and forking the project, creating a merge request, and start exploring. Thanks for having me today. Any final words?
Thank you so much, Michael, for gracing us with your presence and sharing your experience and from your wealth of knowledge. This was really awesome. And hopefully, so our engineers can reach out to you via the social links you shared, right? If they have any other questions.
Yeah, I think it's best to reach out on Twitter or social media, because if you send an email, I'm not reading my emails that often. It's easier to share in the open. And if you want to like jump into specific questions, I would also totally recommend checking out the GitLab community forums, which is forum.gitlab.com, where everyone who has the experiences or wants to help chimes on in, and it's an easier way to immediately get help from experts, from beginners. Yeah, everyone can contribute. So it's faster if I'm not responding to just jump into the forums and get help. Or you can also ping Abu Bakr on social. You can learn more about developer evangelism if you want to, what our team does. We do have a public handbook, or GitLab has a public handbook, and our team has as well. So you can see, just looking up the URL now, can learn and see what we're doing. All the projects, like the Go Tanuki workshop, but also like, yeah, I think it's a lot to see, and we are doing probably too much, but it's a fun job, and I really do love what we do.
Okay, thank you so much. So we have Abubakar on our Slack channel, so I'm sure if they're unable to reach you, they can jump into Abubakar's Slack inbox. Thank you so much, Abubakar, for joining us and supporting today. Thank you so much, everyone, for tuning in. So we will be uploading this session on YouTube, and I'll share the link with everyone by Monday. Thank you so much. Enjoy the rest of your weekend. Bye.
Thank you. Bye.
Bye.